Welcome. You are now tuned in to a brand new type of video that we about to make called Regents Prep ChemTalk with Mr. Brown. Today, we're going to talk about organics. So let's jump right into it. All right. So the first category that we're going to go over of questions for organics are naming. Let's see what it do. All right, the first question. So for each one of these questions, I'm going to have 4 categories of boxes set up for you so that we can go over things. First one, keywords from the question. Then we're going to be known content. What is the known content that we need to know for this question to be able to answer the question? And then do's, what are we going to do for the question? And don'ts, what are we not going to do for the question? So keywords, well, let's read the question first. A molecule of a compound contains a total of 10 hydrogen atoms and has the general formula CnH2n plus 2. What prefix is used in the name of this compound? So, keywords, 10 hydrogen atoms and prefix. Those are the 2 keywords. What is the prefix that we're going to use? And again, hydrogen atoms. We need to know that there's 10 of them. Known content. If we don't know what a formula is and the subscripts that are used in formulas, this question ain't gonna work for us. But what are we gonna do? We are gonna do algebra, right? They gave us a formula, the general. Okay, well, so let's work it out. We have our formula here written. It is CnH2n plus 2. The question, the keywords, we have 10 hydrogen atoms. So let's say hydrogen is equal to 10, because we have 10 hydrogen atoms. We also need to know what the prefix is of this compound. And prefixes are the number of carbons. So once we can figure out how many, what H or what N is in H, then we can use that number to plug it in C and determine what our prefix is. Our prefix table that we're going to need to use is this. And again, that is the number of carbons. So let's see what we do. So 8 is equal to 10 and 2n plus 2 is H. So I can do 2n plus 2 is equal to 10 and solve for n. So first thing I could do, get n by itself, minus 2, 2n is equal to 8, divided by 2, divided by 2, n is equal to 4. 4 is how many carbons that I have, and the prefix for 4 is but. So the prefix that I'm looking for in question number 1 is but. In our next question in the naming and formulas category, a molecule of butane and a molecule of 2-butene both have the same total number of what? The keywords here, same total number. The known content, parts of an organic compound name. If we don't know that, we're not going to be able to understand this question. What are we going to do? We're going to find the trend, and we're not going to use any tables. They're not going to be helpful here. So let's work. Butane and butene, 2-butene, and they both have the same total number of what? We do not have the same ending, but we do have the same prefix. And we just confirmed from our previous question, our prefixes are number of carbons. So our answer is they will both have the same number of carbons. In our next question and final question in the naming and formulas category, what is the total number of shared electrons in a molecule of this substance? Keywords, shared electrons and total. Another keyword could be molecule as well, because we're talking about the entire molecule. Known content, we got to know that their shared bonds are the lines. Our shared bonds are the lines. And 2 electrons per shared bond. So what are we going to do? We're going to use dots to count each line, because we have to keep track of the lines. And then we're going to multiply the line number by 2. We know there are 2 electrons per shared bond. We're not going to use any tables because they're not going to be helpful here. Let's work it out. Okay, so we are going to count the dots of each line. Here's our molecule. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. 11 lines at 2 electrons per line gives us a total number of electrons of 22. Okay, so for our next category in the organics, Regents Prep ChemTalk with Mr. Brown. Single, double, and triple bonds. Let's see what it is. In the first question, a double carbon-carbon bond is found in a molecule of which one of these choices? The key words here, double and bond. We're talking about a bond. That is a double bond. Known content, we have to know the endings of our organic compounds. And not actually memorize, but we have to know how to get them. So what we're going to do, we're going to look at the endings. And we're not going to use any tables because, again, they're not going to be helpful here. This is where our known content comes in. So let's work it out. Okay, for this question, we have the options of pentane, pentene, pentyne, or pentanol. So we are going to look at our endings, and the double-double bond ending is represented by the ENE ending. So pentene is the molecule that contains the double carbon-carbon bond. In our next question in the single, double, and triple bonds category, which formula represents an alkene? Keywords here, formula and alkene. Our known content, the general formulas of hydrocarbons and where to find them, how to use them. That's what we need to know here. What we're going to do, some algebra. Yes, we're going to write out all of our math on paper. We're going to use table Q, or we can draw them, but that takes a lot of trial and error. So we've got a couple different options here, but the algebra is the straightforward right away option that we're going to do. We're not going to do mental math. We're going to write it out. We're not going to use table P. It's not helpful here. We're not going to use the periodic table. Okay, in this question, we need to do some algebra, and we're going to have to use table Q in order to figure out which of these formulas represents an alkene. So our alkenes are represented by the general formula of CnH2n. So we are going to determine which one of these goes and fits in that formula. So with our first formula, we have 2 carbons, C2, H2 times 2. That would give us C2H4. That's not it. If carbon was 3, if N was 3 carbons, we'd have C3H2 times 3. That will give us C3H6. That is our winner. But just for the sake of this video, let's continue. If there were 4 carbons, we'd have C4H2 times 4. That would give us C4H8, and that is not it. If N is 5, we have C5H2 times 5 will give us C5H10, and that is not it either. So our answer is the molecule formula number 2. In my next question in the single, double, and triple bonds category, what is the total number of electrons shared in the bond between 2 carbon atoms? Keywords here, shared electrons, total, and carbon atoms. This is the key here. We're not talking about a molecule, we're talking about the carbon atoms. Known content, again, shared bonds are the lines and 2 electrons per shared bond. So what we're going to do, we're going to look at the number of lines between carbons, just between carbons, and then we're going to pay attention to the wording, because if we're not paying attention to the wording, we're not going to be answering the question correctly. We're not going to use any tables, and we're not going to look at the lines between carbon and hydrogens. That's not in the question. Let's work it out. This molecule, we have 1, to 3 lines between our carbons because they're asking them for the total number of electrons between the 2 carbons. So that is 3 times 2, and that gives us 6 electrons between those. In our next category of the organics, Regents Prep ChemTalk with Mr. Brown, saturated hydrocarbons. Let's see what we got. Which compound is a saturated hydrocarbon? So keywords here, saturated, gotta know what that is. Known content, the difference between unsaturated and saturated. Once we know that, we're gonna be able to do this question as well as if we know how to draw structural formulas. Gotta know that in order to do this question as well. So what we're gonna do, we're gonna draw each option and we're gonna make sure that the atoms attached to the carbons are written, the ones that are written after the carbon, right? So all the elements written after the carbon are the ones that are attached to that carbon. Each carbon has to get 4 bonds. That's what we need to make sure we do. And the bonds are our connections, our lines. We're not going to use any tables and we're not going to mental draw, we're going to put this on paper so that we can see it. Okay, in this question, we are looking for the saturated hydrocarbon. In order to do that, we have to draw out our formulas, our condensed formulas. So we need to remember that the atoms that show up after the carbon are attached to that carbon. So this first one, when we're following our rules of drawing, we start with our chain of carbons. And we can just open them up because this carbon has 2 hydrogens on it, and so does the other carbon. And in order to make sure our molecule is good, every carbon has to have 4 connections. These 2 carbons both have 3. Only way to get my 4th is to create a double bond that is not saturated. Next one. We have 2 carbons again. On each carbon, there are 3 hydrogens. So this molecule actually is our saturated molecule because each carbon has 4 connections, 4 bonds, and they are filled up with hydrogens. This third option, for the sake of our video, we have 2 carbons. This carbon has our 3 hydrogens on it. And this carbon has a hydrogen and it has an oxygen. In order to get our 4 bonds on this one, because this already has 4, and oxygen always will have 2, we'll create our connection with oxygen and double it up. So this is an aldehyde, and this is not what we're looking for. It is not a saturated hydrocarbon. The last one, again, we have 2 carbons. This one has 3 hydrogens on it. This one has 2 hydrogens on it. And it also has a hydroxide group, an OH group. This molecule right here is an alcohol. Once again, it is not a saturated hydrocarbon. In the next question, which formula represents an unsaturated hydrocarbon? So our keywords here, unsaturated. And again, we got to know the difference between saturated and unsaturated. And in this question, we don't have to draw anything. It's already drawn for us. So what we're going to do, we're going to look for double bonds, because that means it's going to be unsaturated or triple bonds. And what we're not going to do is use any tables, and we can't miss the halogen. Halogens are not hydrocarbons. They are branch off. So let's work it out. In this next question, we're looking for an unsaturated hydrocarbon. That means we are looking for either a double or triple bond. In this hydrocarbon, we see it's all single bonds and it's filled with hydrogens. In this molecule, there is a chlorine here and halogen, so that makes this molecule a halide, not a hydrocarbon. Same thing with this one. Even though there's a double bond in our carbons, there is a halogen, so that makes it a halide, not a hydrocarbon. But this is our double bonded hydrocarbon, so our answer is 2. In the next question, which compound is an unsaturated hydrocarbon? So again, keywords here, unsaturated and hydrocarbon is a keyword. known content. Again, the difference between unsaturated and saturated. And again, we have to know how to draw structural formulas because that's how we're going to get these names turned into structural formulas that we can see. We're going to look at the endings and we're going to draw each compound. We're not going to use any tables, and don't let the functional groups trick you. They will trick you. They could trick you. They're not hydrocarbons. So let's work it out. In this question, we're looking for an unsaturated hydrocarbon. So we're looking for a hydrocarbon with a double bond. The ending of a hydrocarbon with a double bond is ENE. So knowing that, we would have been able to answer the question. But if we were able to only draw our structural formulas, we would still be able to determine it from there. And that's what we're going to practice today. So in each one of these molecules, I see hex as my prefix, meaning that in each one of them, there are going to be 6 carbons linked up. Sorry about that. 1, 2, 3, 4, 5, 6. The next step is going to be to draw your functional group, add your functional group. And in this case, we have anol, A-N-A-L. And if we look at table R, our ending of A-N-A-L is represented by aldehydes. So I can see that. It's represented by aldehyde. So that means our carbon is going to have a double bonded O, a carbonyl group, and it's going to have a hydrogen at the end. Let's put this hydrogen here, and our double bonded oxygen, our carbonyl. And then from there, we are just going to fill out our carbons with the proper number of hydrogens. So each one of them is going to get 2. And for the sake of time, I'm not going to fill in the hydrogens, but each of these lines would get hydrogen, would get a hydrogen atom. For the next one, again, we have 6 carbons. 1, 2, 3, 4, 5, 6. Anoic acid is our ending, and as we can see from here, anoic acid is an organic acid. And organic acids have a hydroxide group hanging off of that last carbon, and that last carbon is a carbonyl. So we will add our carbonyl, we will add our hydroxide group, and then we will add the rest of our hydrogens. In our next one, hexane. It's 6 carbons. 1, 2, 3, 4, 5, 6. And they are all single bonds, and it is a saturated hydrocarbon. So we are just going to add our hydrogens. In our last example, we have, again, 6 carbons, and we have a double bond. So between the first and second carbon is a double bond. That means this carbon would get 2 more hydrogens, and these would all get 2, and this last one would get 3. So again, our answer, the unsaturated hydrocarbon, is that answer number 4. We could have figured it out by knowing that our ending of ene has a double bond. In our next category of this organics Regents Prep ChemTalk, isomers. Let's see what we got. Which 2 compounds are isomers of each other? So keywords here, isomers. What we're going to have to know, molecular formulas and the definition of isomers. And condensed formulas as well, because these are all condensed formulas. What we're going to do, we're going to count the number of atoms in the first option for one element at a time. One element at a time. Then we're going to check the second option to compare the element and make sure the numbers are the same. If they're the same, we got our answer. We're not going to mental draw. We're not going to look at the periodic table. And ultimately, we're not going to draw at all because we don't need to. So let's work it out. Okay, in this question, we're looking for isomers. Isomers have the same molecular formula, different structural formula. So we need to make sure there are the same number of each atom in either molecule. So let's start with the first one, and we're just going to count to see how many carbons, hydrogens, oxygens we have in both of them. In this side, we have 1, 2, 3 carbons, 5 hydrogens, 6 hydrogens, 6 hydrogens, and then 2 oxygens. In this one, we have 1, 2, 3, 4 carbons. We're going to continue, though, even though we know now carbons don't have the same, so it's not going to be isomers of each other, but 3, 5, and then 8 hydrogens, and then 2 oxygens. So that's a no-go. Next one, we have 1, 2, 3 carbons. We have 5, 6 hydrogens. And we have 1 oxygen. On this one, we have 1, 2, 3 carbons, 6 hydrogens, and 1 oxygen. This is going to be our answer. But again, for the sake of the video, let's continue. 1, 2, 3 carbons, 4, 7 hydrogens, and 1 Br. In this one, we have 1, 2, 3 carbons, 3, 6 hydrogens, and 2 Brs. This last one, we know that's a no-go. We have 1, 2, 3 carbons, 4, 5, 8 hydrogens, and 1 oxygen. So 1, 2, 3 carbons, 3, 4, 5, 8 hydrogens, and 2 oxygens. So that one's a no-go as well. Again, isomers, we're looking for the same molecular formula, so the same number of each atom, but just a different. In the next question of isomers, which formula is an isomer of this compound? This one that's up next to the paragraph. Keywords here is isomer, known content, structural formulas, and the definition of isomers. What we're going to do is we're going to count the number of atoms in the compound, one element at a time. Then we're going to check each option to compare the elements and make sure they're the same. We're not going to mental math it, and we're not going to look at the periodic table. Let's work it out. In this example, I need to find the isomer of this example, or this molecule right there. We have 3 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and 1 oxygen. So let's find the molecule that matches that. 1, 2, 3 carbons, 3, 4, 5, 6, 7, 8 hydrogens, and 1 oxygen. The answer is going to be our first. Over here we have 1, 2, 3, 1, 2, 3, 4, 5, 6. That's a no-go. 1, 2, 3, 1, 2, 3, 4, 5, 6. Again, no-go. And then 1, 2, 3, 4, 5, 6. 1, 2, 3. Again, no-go. Our answer is no. In our final category, condensed formulas. Let's see what we got. The organic compound represented by the condensed structural formula of CH3, CH2, CH2, CHO is classified as in what? Which option? Keywords here, classify. That means we're going to have to identify what that condensed formula is represented by. Known content, how to draw structural formulas of organics with functional groups, because this oxygen at the end of our condensed formula has tells us that this is a functional group. What we're going to do, we're going to draw it out. We're going to make sure all of the atoms attached to the carbon are the ones that are written after the carbon. And then each carbon gets 4 bonds. We're going to make sure those connections are right. We're going to look at table R for functional groups. That's going to give us our identity. We're not going to mental draw it, and we're not going to look at the periodic table. So let's work it out. In our last example, last question, we have to draw our condensed formula. We're going to open it up, and then we are going to figure out which one of these it is. So we start off with 1, 2, 3, 4 carbons in our main carbon chain, in our parent chain. This carbon has 3 hydrogens. This carbon has 2. This carbon has 2 as well. And this carbon has a hydrogen, and it has a carbonyl. This oxygen is double bonded to it. So if we compare this and look at our table R, we will confirm and see which one of our groups, our functional groups, does this structural compound represent. the carbonyl to an carbon to oxygen, carbonyl with the hydrogen tells us that it is an aldehyde. So our answer is that it's an aldehyde. There you have it. Thank you so much for watching. It's the Organics Regents Prep ChemTalk with Mr. Brown.